Can you hear me? Yeah, okay, good. Attendance, right. All right, sorry for today's lecture. It was actually due to yesterday was a public holiday, and it's already struck us a number of times on Monday, which is a holiday, and they already create problem to our schedule. And then furthermore, the coming the coming Saturday there will be a quiz which is on this topic. You see, so if we do not go through these topics, then I think that it will be unfair to all of you. And then just happened that on Tuesday we have another 2-hour sessions which is pre-allocated for our timetable. So I'm lucky. I would say we are lucky here to be able to make use of these 2-hour sessions for our lectures, and so that we can do the catch up so that it is actually in line with the schedule. Okay, let me get started with this. So let me share my video a bit. All right. So I believe all of you have gone through the lecture video, and also you have an idea of what we are going to talk about today. So let me do some adjustment. And yes, this one. This is actually on now we are moving on to layer 3. Still remember, whatever that we have done before this is on layer 1 and layer 2. Now we are slowly climbing up the OSI layer into layer 3, which is very much on logical, which is actually on logical addressing. So in this network layer, what is important is actually logical addressing. And we remember that we will have a physical address, and physical address is not a physical layer. Remember this? Physical address is not a physical layer. Physical address is at the second layer, at the data link layer. Layer 2, we will have physical address. We will have the hardware address, and it is also physical address is equivalent to hardware address. Okay? So those are the things in layer 2. Why they are called the hardware address, and furthermore, they are not at the physical layer. It is because when a network adapter is being created, layer 1 and layer 2 is always coupled together. They always couple together. That's why it's come with the network hardware. So layer 1 and layer 2 is always come with the network hardware. You cannot separate them. So when you buy a network adapter, or what we call a network interface card, NIC, is always come with layer 1 and layer 2 together, and you cannot separate them. That's why the second layer, the layer 2 address, which is the MAC layer, the MAC address, the physical address, so and the hardware address, they are all referring to the same thing. So it's all on layer 2. And now, when we go into layer 3, which is actually logical. Logical means it doesn't tie to the physical anymore. That's why it's called logical. Meaning to say, this logical address, this layer 3, is very much a software implementation. It is a software implementation at layer 3. And when you want to talk about software, it is actually most of the time this layer 3 software, this layer 3 protocol software is actually sit in the operating system. It will sit together with the operating system. I hope you still remember what is operating system. Computers can work because of there is a basic set of software called operating system. So you install your application software on top of this operating system so that you can use the software. Okay, so you have this fundamental software called operating system, and our layer 3 protocol, layer 3 network layer protocol is also a software implementation. So it's just another software installed together with the operating system, and it will provide all the layer 3 functionality through the software. And more importantly, the main purpose of this is actually to address. Okay? At layer 3, you can do routing. It's always based on the address. And this address is what we call logical address. And when we talk about TCP/IP, right, the internet is running on TCP/IP protocol. TCP/IP protocol is a software implementation which is covering layer 3 and layer 4. TCP in layer 4, IP is in layer 3. So IP is the one that we're going to talk about today. IP, Internet Protocol. So we are going to talk about Internet Protocol address, which is one type of logical address in this context. So I hope this one will get you clear. So when we talk about the Internet is based on TCP/IP protocol, so it is referring to layer 4 and layer 3 implementation. You can use any of the hardware, any of the layer 2 or layer 1, okay, regardless of what type of layer 2 or layer 1 that you are using. But as long as your computers can run TCP/IP protocol, which is the TCP/IP software suite, then you will be able to be part of the internet. You just imagine when you are using a computer connected by wired, right? Connected by UTP cable, you can go to the internet. If your laptop is using Wi-Fi connection, you can go to the internet. So it's the same thing, The protocol is the same, but the underlying layer 1 and layer 2 is different. It doesn't really matter. It's okay. But what the internet care is only layer 3 and layer 4, right? So layer 1 and layer 2 is actually the technology, the network technology, mainly for the local area network. Okay, physical, the physical one. So you get this picture clear, and we talk about this, then you will be much easier for you to actually make relation of your knowledge that you have learned before this. So layer 3, we are looking at routing. Routing happened at layer 3. And then the whole internet is all about routing. The whole internet, if you still remember carefully, the whole internet is made up of routers. The whole internet is all the routers interconnect to each other. Even your home network. Okay, you are subscribing to your Unify. You think that you are not using a router, you are using a router as well. The device that TM provide to you is called a Wi-Fi router. So it is a router as well. So the moment when you switch on that device, that device connect to TM's network, which connect you to the internet, that your device at home, that one is a router. So the entire internet is based on router. And then for router to operate, you must have IP address. Okay, so this is the whole idea, the whole concept. And today we're going to talk about the formatting of this IP address in specific. Of course, in layer 3, there are more than one layer 3 network layer protocol. It's just that IP address, Internet Protocol, is the most popular one now. And there are many others that are not popular. We are not going to talk about it because no one is using them now, you see. They have been obsolete. That's why when we talk about network layer, automatically our mind switch to the example. It is Internet Protocol, okay? IP. Okay, so this one I have mentioned to you. Network layer, layer 3, we are talking about all the logical addressing. And the address here, this IP address, the IP protocol come with an IP address, and then this address come with a format. And each of the address defined here is actually the most common one that we are using now is IP version 4, IPv4. Okay, you can see IPv4 is the one that we are using now. So it consists of 4 bytes in length, which is actually total 32 bits. Later we'll look at the format. And the new generation is called IP version 6. Version 4, then later version 6. Why? Because version 4 has got some limitation. Last time it was fine. But after people use it for some time, IP version 4 cannot cope with the needs of today's internet usage. Today, internet usage, how many users are there in the internet? There are more than 7 billion, you see. The number of devices in the internet is more than the population of the human species. So IP version 4, based on 32-bit, okay, based on 32-bit address length, cannot provide enough address. So basically, now our internet's running out of address. We do not have enough IP address for all the devices in the internet. There are way too many devices in the internet that we couldn't provide sufficient address. But why are we still be able to use the internet now, even though our internet is running low of IP addresses? Because based on the rules, each of the device that appear in the internet must have a valid public IP address. It must have a unique IP address, just like your IC number. You cannot have duplicate. Okay, so your IC number will also run out if there are too many of you born on the same day, right? Too many of you born on the same day, your IC number will also run out. Suddenly, 1 million people born on the same day, and then your IC only has got 4 digits, right? At the back, only got 4 digits. Sure, you do not have enough. Your digit is not enough to accommodate 1 million babies that born on the same day. So the same thing happened to IP version 4. But there are some clever people out there has managed to create some alternative solution. Later we will talk about this a little bit. So IP version 4, we can still use it, but with some innovation. And then people are still quite happy with this alternative. Right? Supposedly, when your IP version 4 run out already, you're supposed to be moving to the newer version of the IP, which is IP version 6, which is actually 128 bits in length. 32-bit compared to 128 bits. Of course, 128 bit will be able to give you more addresses. So based on 128 bits, your IP address will supposedly will never run out because the number is so big that you are not supposed to run out. So IP version 6 has been delayed. So the adoption of IP version 6 has been so slow, and most people on the internet is still using IP version 4 until today. Okay? So this is a sad story because IP version 6 is not only offering just more addresses, but they offer extra feature as well, such as quality of service, which is actually getting more and more important in today's network application. You know what this quality of service for? When you're actually doing real-time traffic, when you're delivering real-time traffic, such as video conferencing, voice over IP, these are real-time traffic. So you are running on IP version 4, there is no guarantee, there is no guarantee of your smooth delivery of your time-sensitive traffic. But IP version 6 comes with extra features that will actually allow you to deliver better delivering of time-sensitive traffic. That is what we call IP version 6 provide better quality of service. So there is a features called quality of service that you can enable for real-time traffic. But IP version 4 has been there for ages. It was ancient dinosaur. That's why last time people never deliver real-time traffic. That's why it was not being designed to deliver real-time traffic. But again, you may ask, but now we are using IP version 4, and then you can still listen to me now in this session here, and then it's actually quite smooth, you say, and then we are doing video conferencing now, you see, live, That's why this is real-time traffic. But how come it can still work? Yes, it can still work. Why? Because your bandwidth, your internet connection bandwidth, and my internet connection bandwidth is fast enough to deliver all those things fast enough. That's why we don't feel any problem. There is no traffic jam in our network. That's why you will find that we can still do video conferencing successfully without any problem. We don't, even though IP version 4 doesn't support quality of service, but your video conferencing session will still be so perfectly smooth. It is because of your internet is fast enough. Imagine your internet is congested. Then for sure you don't get this kind of smooth experience. Then during that time, you will seriously need IP version 4 quality of service features to ensure smoothness of real-time traffic. It is something similar to the ambulance. When you have traffic jam, if ambulance do not have that siren, no one is going to give way to your ambulance, you see. So your ambulance will not be able to arrive at the hospital in time, in the shortest possible time. So IP version 6 is basically allowing this priority service. So you can put a siren, other people see it, other people automatically will give way. So same thing happened. So this is what we call quality of service in a network traffic. Right? So I think when you go deeper into network, this is very interesting that some of the networks support better quality of service, some of the network do not support quality of service at all. Right? So these are some of the things that we will go through. I mean, if you go through it deeper, then you will see some of this. Right, so again, go back to IP version 4 addresses. It's 32-bit divided into 4 byte. 1 byte is 8 bit. 4 times 8 is 32, right? That's why it comes with 4 digits. Right? So, and then each of the IP address appear in the internet must be unique. So the meaning of unique is that there is no duplicate. It cannot have duplicate address. That's why we can run out. If we can allow duplicate, then we will never run out. Because it doesn't allow duplicate, all the units, all the computers that appear in the internet must have a unique IP address. So that is actually the requirement. So 32 bits will run out. So this will give you like something like a 4 billion start of number of address, which is actually not sufficient. I mean, based on today, if you imagine Unimas is a big campus, I would say. Unimas, how many users, how many students? We will have like something like 16 or 17,000 students, exclude staff. So you include all the staff, include some other admins and some other people. I think we will have like close to 20,000 users of the internet on campus. So imagine one organization, like one university, already take up like 20,000 IP addresses. So there are so many organizations out there. For sure, 4 billion is not enough. But to be honest with you, Unimas is using the alternative technique instead of allowing all the computers in the campus to have a unique IP address, but they make all the IP address private. They don't make it public. So they are using a technique called network address translation, NAT. Now remember this keyword NAT is actually a technique that used in almost all the home routers that you are using now, even Unify that you are connecting to, the router that you are using, they also enable NAT. So all of you in the private network will share one public IP to access the internet. That means Unimas with 20,000 computers, for example, 20,000 users, Unimas just need to have just one public IP address, one unique public IP address to be able to allow 20,000 users to share that particular public address to access the internet. So this is a technique. We call the network address translation, NAT. Right? So this technique enable, that's why we don't bother, not enough IP address. It's no big deal, you see. Why? Because we got NAT technique, we can create private network that is not visible to the public, but you can still allow them to access the internet. But if you are hosting server, you cannot. As a user, you just accessing the network. People do not access you. You access other people, okay, fine, using this technique. But when other people want to access you, you cannot. So when you want to host a server, your server must have a unique public IP address. Right? Of course, some of the server like Ellipse, Ellipse will have their own address, and then different server in Unimas will have different address. That's why Unimas will probably run on maybe 10 or 20 public IP address, and then the rest are all private. Private is the one that cannot be seen by other internet user. Right? It's only internal. It's only internal. That's why it's called a private network, and the internet is a public network. Right? So you have a device in between to do the translation. It's called the network address translation. So through that, we never have to worry about not enough IP address. Okay, so that's the whole idea. Okay, so let's look at some of this notation. You look at the format like this, it's easy. So it's always come in 4 digit for IP version 4. It's always come in 4 digit. So each of the digit here, for example, this is 1 digit. 1 to 8 is 1 digit. Okay, 11 is another digit. 3 is another digit. Okay, it's always 8 bit. 8 bit. So you see 2 power of 8. You tell me 2 power of 8, because it's 8 bit, go to 2, 5, 6. Right. 2 power of 8, because each of the digit is actually, each of the decimal is actually 8 bit. So a total number you can have for each of the decimal is actually maximum 256. So meaning to say the value, take this thing, the value is range from 0 until 5, 5. Okay, it's between 0 to 255. Add up to be 256. 0 is also counted as one number. 0 counted as one number. So each of the octet, we will call this the octet. They got 4 octet here. Each of the octet here will have a number between 0 to 2, 5, 5. So you have 4 octet, so 40 to 255. Right. So if you write any number that is larger than 255, then it will become invalid address. So let's say if you want to write something like 365, okay, my IP address is 365, dot something, dot 100. So this address is wrong. This one is wrong. So there's no such thing as 365. Maximum you can have is 255. Right? So you must understand this because each of the octet is only 8 bit. 2 power of 8 equal to 256. So maximum number you can have is only between 0 to 255 only. 0 is a number. So 0 is counted as 1. So 255 plus 1 is 256. So I hope it is clear. You just need to know the format. So when you see all this number here, you know the limit, you know the restriction. Then there will be. So these are some of the examples that I'll leave it to you. So you know that it's easy. Okay. And then these are actually got two different types of addressing. One is called the classful address. The other one is called the classless. Classful means got class. So what are the classes? Classes, they are all together 5 classes. Classes is class A, class B, class C, class D, and class E. Okay. So how do they be determined? So you can see that, class A is the first byte is actually, cover the first octet. So the class B cover the first and second octet. Class C cover the first 3 octet. So the first 3 octet are actually being used as, they're actually divided into 2 portions. One part is network ID. The other part is not ID. So in an address, they got 2 portions. One portion is for network ID. The other portion is for host ID. Host is actually your computer. Okay? End user device is called a host. And net ID is actually the network, something like network ID is something like, how do we call it? Room just like something like room number. Okay? Just something like a room number. How many room number can you have? Okay, if you look at class A will have only 1 octet only, right? 1 octet is only 8 bit, right? So 2 power of 8, you only get how many network can you have? How many room can you have? It's only 256. Now you can look at the class B. See, class B is different. Class B now taking 2 octet here, 1 and 2. So 2 power of 16. 2 power of 16. 2 power of 16 is actually 64,000. 2 power of 16 is actually 64,000. So you can have 64,000 network or 64,000 room. So more network, see. And then class C is even more, see. Class C is 2 power of 24. 2 power of 24. So you know that 2 power of 24, you get even more number of N network. But when this one taking up 3, you see, 3 octet, then you're only leaving just 1 octet for your host ID. So meaning to say under a class A, see, class C, this is class C. Under class C, you only have this many, of what we call the host. Host is actually the user. How many hosts? How many user can you have? Only with 1 octet, it's only 256. Maximum 256 user. See, class C support the small number of user. Okay, so there is only 256 user. So if you look at class A, which is covering 1, 2, 3 byte, so it's 2 power of 24. Okay, 2 power of 24, you get how many? You get a lot, you see, you get a lot of user. So the number of network is less, but each of the network will have a lot of user. So this is actually the definition of classes. So most of the time we use class A until C. Class D and E, partly we are using because they are very specific. They are only a certain range only. They use only certain range, if you can see. Okay? They use only certain range of address, very little. So usually class A, class B, class C. So these are actually all the classful address. So meaning to say, if your organization, for example, let's say 2 power of 16, let's say if you are talking about, okay, one organization, this is a big organization, let's say Unimas. Unimas say that, I need to have, my campus probably will have like 60,000 users. I will have 60,000 computers in my campus. So Unimas should apply for a class B address, at least a class B, because class B is 2 power of 16 number of network. Okay, and then your number of nodes here is also 2 power of 16, which is 64,000 nodes that you can have. So if you're expecting your campus to have 60,000 computer, so you should apply, your campus should apply for a class B address, at least a class B. Okay, so if your organization is actually larger than 64,000, let's say you will have 100,000 computers, then you probably have to apply for a class A address. Okay, class A will support more than 64,000. Anything more than 64,000, only a class A address can support. But only based on this format, in the whole world, only 200 plus organization can apply for class A address. But our world is such a big world, right? 200 plus organization only, so that is surely not enough. Okay, so this is what is the mean by class. So they divided into different classes. Class A has the most user. Class B up to 64,000. Class C is the smallest. Class C will only have 200 plus user only. Okay, I don't want to say 256 user. I know 2 power of 8 is equal to 256, but it is not true. You cannot have 256 user. Why? Because on every IP address, the first address and the last address cannot be used. So the most you can have is only for class C. The most, instead of 256, you only have 254. 254 number of users. Because the first one you cannot use, the first address, the last address you cannot use. The first one is used as a network address, network ID. The last one is used as a network broadcast address. So you cannot use these two as a valid IP address for your computer. And so I hope this is clear to you. So obviously these are classful type of allocation, address allocation. This is actually what we call when you want to be part of the internet, you want to apply for IP address. There is an organization in charge of address allocation. So they will have 3 different classes of address. So they will allocate to you. You basically have to buy basically. It's not allocate. You have to buy, depending on the size, the number of address that you want. So they sell you class A, class B, and class C type of address. Okay, but obviously it is not enough. The number of users in the internet, the number of organizations is so many. So you do not want to share. That's why this type of classful addressing are not very efficient because they are so limited. You cannot go for, let's say if your organization has got 300 people, but your class C address can only support 254 address only, but you need 300. People call it alang-alang, it's not so many. That's why you have no choice. You have to apply for a class B address. So class B is way too many. Class B has got 64,000, but you need only 300. So the next one is 64,000. So when you apply for a 64,000 address, you have to pay for 64,000. And most of the time you are not using them. When they allocate to you, you are not using them because what you need is only 300. But 300 cannot fit into class C. Class C only 254 number of nodes only. So that's why I say it is not flexible, this sort of classful address. That's why nowadays a lot of people, they use classless addressing. Later we will look at it. Classless addressing do not go by class ABC anymore. is go by subnet mask. How many you want, I allocate how many for you. And how do you determine? We use a subnet mask to actually determine your network, or how we call your network address, as well as the number of nodes that you need. So this is actually the story about IP. So you can see that the IP format got two portions. One is for network address, the other one is host address. Right? So depending on which class of IP, okay, class A will only have a shorter. Class A will only have this part only lah, as a network. So the other 3 octet will be used as, sorry, let me still blocking me. The other 3 octet here will be used as host ID. Host ID is your host refer to computer or internet capable device. Host. So when you understand the word host, host refer to computer, can refer to your smartphone, your tablet, your laptop. They are all hosts. Okay? And then network is a network. Okay? One network consists of how many hosts. So it's, network ID is very much a grouping. Right? It's a grouping. So these are, how does it look like? So I think it's easy, straightforward. You can, based on this diagram here, then you know lah. The net ID for class A is so little, only 1 byte. 1 byte maximum network you can have is only 256 network only. Okay, but of course each of the network you can have a large amount of nodes or large amount of hosts. So class C is the one that you use when you are actually, imagine you got your home Unify, your Unify router is definitely running on class C. Okay. Okay. This is actually a private network that you are creating lah. So you can see that sometimes it is actually a maximum of 254 computers in your network. So class D multicast, class E is reserved. Class D reserved for multicast, and class E is actually reserved for future use. So these are the examples. So I leave the example to you. I think through the example, it's very easy for you to actually see. So I think I've just explained this to you. Okay. So class A. So you have number of IP address can up to 16. Oh, sorry, it's not 64,000. Sorry, 16,000. 64,000 is how many bits already? So this one you use a bit of calculators lah. 2 power of 16. Sorry, this is not 16,000. This is 16 million. Sorry, 16 million. Class A 16 million. Just now the one class B 64,000. That was correct. 2 power of 16 is 64. Yeah. So this will explain. Yeah, 64. But it's written as 65. Okay. But usually we call it 64. Why? You refer back to your computer architecture, then you know why. Why 1 byte is 1 kilobyte is how many bytes? So that is actually the answer. So when you actually divide this 65534, actually 65536 divide by 1024, you divide it for a few times, then you will get 64. So that's why when you actually buy some memory storage, when you look at it and say, how come I am buying 32 gig, but I get more than 32 gig? No, it is not. It is because of you have to divide by 1024. Okay, 1 kilobyte is not 1,000 bytes. It's 1,024 bytes. This is not like you buying sugar or you buying salt. You go to the shop. I want to buy 1 kilo of sugar. You only get 1,000 grams. But here, because of the binary system, okay, so you get you don't get the exact number. So next time when someone asks you, right, then you can explain. So class C 2 power of 8. So you basically have to minus up 2. Why? Because the first one, the first address and the last address you cannot use because they have specific purpose. So you only have got 254 possible IP address for Class C. Okay, so these are actually the summary lah. So, and most of the address are actually unicast. Unicast, what is different between unicast and multicast is that unicast is one-to-one type of communication. Multicast is actually when you send to a multicast address, you are sending to a group of hosts. A group of hosts. Something like your WhatsApp group lah. Say your WhatsApp group has got how many people. So I send one message and all of you get it. So when you want to send a private message to me, that is unicast. Right? So multicast I can analog to you is that when you send to a group, so everyone get it. You send one message, everyone get it. So that is multicast. You want to send a one-to-one, that is unicast. Right? So I hope that is clear. So classes and blocks. So I think these are straightforward lah. Is the net ID, host ID. Something like net ID, host ID. I think it's actually referring to this one. Okay, this is net ID, and this is host ID. Right? So it's the same thing, just different name. So you can see class A, the net ID, okay, is 1 byte. So in order for you to create the mask, okay, the mask is actually to mask the host ID, the node ID. So that's why you were all started with 1. So why they are all 1 is because of they are doing an AND operation. 1 and 0 is going to be 0. 1 and 1 is only to be 1, right? So that is actually the whole idea. That's why you can see the mask. For the first one, class A is actually 255 dot 0 dot 0 dot 0, because this one is 0, this one is also 0, this one is also 0. So you can see the class B is going to be 255.255.0.020. And then class C is going to be 255.255.255.0. Okay? So this is what does it mean? So you look at the CIDR, the classless interdomain routing. So the /8 is actually for class A, /16 is for class B, /24 is for class C. Then you may ask, can I /23? Yes, you can, under CIDR, which is classless notation, you can /23, you can even /28, okay? But this is just an analogy that, class A is basically /8, class A /8, class B /16, class C /24. But under classless CIDR notation, you can even have /23, 22, 20, okay? So it's actually, what does it mean by this /8 here? CIDR /8. This 8 here refer to the 8 bit here. As you can see the 8 bit here. This is 8. This is 8. And this one /16, class B, from here to here, this is 16. And this one is 16. This is 16. So /16. So 24, you know the answer. 24 is because of this one. 8 plus 8 plus 8 altogether 24. So how about 25? So how are you going to write 25? You want to /25? 25 means here, this one will have to be changed to 1. You see? This one, this particular one will have to be changed to 1. So that is /25. How about /26? /26, this one also changed to 1. This is not 0, but this is 1. So that is /26. So you want to /27. This one put a 1 here. This means basically /24 means you got 24-1 for your net ID. So when you have 3-1 here, just based on this example, based on here. So you only got how many 0 at the back? 1, 2, 3, 4, 5. 5. So how many node ID can you have? So this one is actually 2 power of 5. 2 Power of R5 is actually how many? 32. Okay, you can only have 32 horse only out of this. 32 minus 2 is actually 30 only. You can only have 30. Okay, so you want to allocate 30 address to an organization, so you have to use /27. Okay, /27, then you will be able to allocate 30 address to one organization. Okay, so this is actually the beauty of CIDR, classless interdomain routing notation. Okay, so it's so flexible. The standard one that we're using is /s/16/24, but you can do even /27, /28. Okay, it's not a problem. If you know the calculation, then you can have more network. Okay, more network allocated for a smaller organization. Okay, so if you look at this one, this number here, this is 254, this is 255. Then you tell me what is this? 254 is actually referring to this one. Sorry, 224 referring to this one. This is the value for 224 if you do a binary to decimal conversion. So you will get 224. So this is, what does it mean? So it's all about bits. So subnetting, subnetting is allow us to create, being very flexible about, playing around with the NAC ID and the host ID lah. Okay, NAC ID means number of network that you can have. You have a larger NAC ID, you can have more networks. That's why Class C has got the most network, but each of the network only can have 254 hosts only. But Class A have less network, 254 network, but each of the network can go up to 16 million number of hosts. And so this is actually the difference. So we have an issue of address depletion. That's why people use classless addressing to solve the problem. So classless addressing, as I mentioned to you, as you can see from here, okay, oops, gosh, see from here. So this is, okay, this is 2 power of 1 here. You see this particular bit here. This one is actually /25. It's 25 because you got 25 one bit here. This is 8 plus 8 plus 8 plus 8 plus 1. Okay, 3 times 8 equal 24. Then plus another one, 25. So this 25 referring to number of 1 here. So the number of 0 behind is going to be less. So this one got 2. So this is /24 plus 2, 26. Okay, so as simple as that. So the smallest network you can have, is actually this one. So this is /30 /30. Okay. So this is probably the smallest network you can have, which consists of only 2 power of 2 equal to 4. 4 minus 2 equal to 2 nodes only. You must remember, this one only got 2 digit here. See, 2 digit only. So 2 digit is 2 power of 2, which you get 4. 4 is 4 hosts only. Okay, 4 hosts minus the first one and the last one cannot use. So you have minus 2 again. Minus 2. So you get what? You get only 2 hosts. So that means this network can only run 2 computers. Okay? This network only can provide address for 2 computers only. So if you are /30, this network only got 2 computers. So that is actually how flexible we can play around with the number of IP address, not according to the fixed class, but now we can be very flexible to play around with the number of host ID, number of host ID bit, then provide the required number of host ID required by an organization. So so I will leave the example to you. So now you know. Okay, these are the things. I will leave the example to you. So it's just some calculation. But the example is actually good for you to go through. Really will really help you a lot. And this thing, sometimes we don't use it too much, then sometimes we can tends to forget. When we tend to forget, we just have to do some revisions. So the whole idea of subnetting is to create more networks. Like instead of having a network that consists of everyone sitting on the same, can see each other's, okay, under the network. But now you divide them into 3 different separated network, okay, it's all connected through a routers. And then these 3 networks will maintain their own collision domains. They don't collide each other's, okay. The network is actually smaller, so it will be more efficient. So you must understand the advantages of subnetting is actually to improve performance and speed. Because why your broadcast domain and your collision domain has been reduced to a small number. So when you have a smaller number of device in one domain, then you will probably have better performance. So you don't have to wait for each other's. Right? You don't have to interfere each other's. So by doing that, you also reduce network congestion. Why? Because your network will always broadcast. Every time broadcast, everyone broadcast, then there will be a lot of traffic. You remember your network can broadcast. You can broadcast message to everyone, right? So these are some of the advantages like boosting network security, control network growth, and easier administration. These are some of the associating advantages. So I leave the example to you. I will not explain the example. But I want to tell you that one IP address got 2 portions. One portion is called the net ID, the other portion is called the host ID. Net ID is indicating the ID for the network. For example, I give you one example, 192, this is common, 192.168.1.0. So this is a network ID. Okay, anything .0 usually is a network ID. So inside this network, you can have 192.168.1.1.1, and then you can have .1, .2, and .1, .3, until all the way you will get 254. Okay, so these are the unit address. That's why for this type of network, okay, you will only get 254 hosts or inside your network. So that's why I don't want you to confuse. It's just one address. Okay, this address is allocated by an authority, and most of the time you have to buy, it doesn't come free. Okay, so this is how you manipulate the address. So network address translation is a solution for you to actually resolve the problem by creating an internal network that is not visible to the internet, but all the nodes inside the network can access to the internet. So what happened to the gateway is actually the gateway act on behalf of all the other nodes inside the network, and act on behalf for them to retrieve the information from the internet. That's why we can have a lot of addresses when we're using network address translation. For example, Unima is also using this. Unima is also using network address translation, and we are using a class A. We are using a class A private address. And so if you see Unima's IP address started from 10, okay, so those are actually the class A address. But they are private. Private means that they cannot be seen by anyone in the internet. But you can access the internet, of course. But people cannot access you. So when you host a server inside this private network, so the whole world cannot see your server. So that is actually one of the disadvantages. The whole world cannot see your server because your server is sitting on a private segment and having a private IP address. So you want your server to be accessible by anyone, right, in the internet. So you must allocate a public IP address for your server. Then the whole world can see your server. But that's why if you put it inside a private network, okay, then you won't be able to see them. Okay? You cannot access. I'm talking about server. What kind of server? Website. Okay, a website. A web server is a website. When you go to google.com, there is a website. When you go to microsoft.com, there's a website. You go to unimas.my, there is also a website. So those are actually web server running. Okay, and then of course, IP version 4, not enough. So the immediate solution, the long-term solution is actually using IP version 6. And IP version 6 come with all the features that they will address all the problem, almost all the problem of IP version 4. But the thing is, the adoption rate for IP version 6 has been so slow. People think that IP version 4 can still work, so why do we bother, to use IP version 6? No need lah, because when you use IP version 6, you may have to upgrade all your equipment, you see. It's because not all the equipment support IP version 6. I know the new one support, you see, but some operator, some company invested on network equipment that is already more than 10 years. They've been using it for more than 10 years, and then the equipment is working just fine. There's no reason for you to upgrade them. Certainly, by upgrading them to support IP version 6 looks not too clever. And because of that, that's why a lot of people are still running on IP version 4 capable device. And a lot of old device still do not support IP version 6. That's why when you go for the upgrade, you have to buy the latest one, and that will cost money. So a lot of people think that not necessarily. After all, IP version 4 can still be used. We just use it, use it until one day cannot use. Then we're only thinking about the upgrades. That's why the rollout of IP version 6 addresses is actually not smooth. It's actually got stuck for many years. And same thing here, IP version 6 of 128-bit long, it's come with 8, not to say octets, so yeah, byte, I mean, 8 bytes. Sorry, 16 byte. On each of the digit, we call it 16 byte. No, 1 byte. Sorry, still 1 byte. But we have many of them. This is actually 2 bytes here. 1 byte, 2 bytes. 1 byte, 2 bytes. Okay? So altogether 16 bytes. And add up to be 128 bits in length. Okay, so I hope this will actually clear some of your, give you some better picture. You just have to remember that, this address, everyone should have an address. But when your organization, let's say your company, wanted to be part of the internet, so you want all your computers to be seen on the internet, so you have to buy. You have to buy from someone the IP address. You buy means you rent. Usually you rent. You rent it from your internet service provider, and then you can make use of this range of address that is allocated for you, and you will be able to host your server and all the stuff. If you are not hosting server, it doesn't really matter. If you are not hosting server at all, you are just an ordinary internet user, then you can just using NAT with your router, run NAT, and you can just, everyone can share the same IP address to get out, to get into the internet, to reach the internet. As simple as that. But if you are hosting server, such as you want to host server like Ellipse so these are actually server. You want it to be visible to everyone out there in the public. So you must say your web server must have an IP address that is actually public, right? And unique. But for the rest of the user, not necessary. They need to have a public IP, but they can always share. They share one to many. To share one, they can use, everyone happy. You just need one to share by a lot of people. Okay. I would like to take questions. Any questions? I mean, this one is not supposed to be too difficult, isn't it? It is just a matter of introducing the IP address formatting to you, and then how do you do the calculation, and it's straightforward. Just remember, all the IP addresses are inside Unimas campus. Even though we are in private network, But within the private network itself, all our IP address also cannot conflict. Every computer must maintain a unique IP address within the same private network. Because this private network cannot be seen by the public, so it will not conflict with the public. But internally, it can still conflict. Why? Because the same IP address appear in the same network. Then that is a problem. That is not allowed in the TCP/IP in an IP network. Okay, is everything okay? You get the idea, right? And I wonder why no one is actually asking. Why no one is actually asking? We talk about IP version 4, IP version 6. What happened to IP version 5? Yeah, someone finally asking that question. Why there is no IP version 5? This IP versioning is, when it's first started, it's always an experiment. Okay, it's always from research. Okay, so when people has been trying to, that's why you may ask, why there is no IP version 1, no IP version 2, version 3? Then why are we using version 4? Are we ever using IP version 1 or 2 and 3 before? No. Okay, we never use that. Those are actually early proposals that are not make it for adoption. When you start to experiment something, then I call this is version 1. But version 1 is not good enough. That's why you create version 2. Obviously, you're not going to use version 1 because version 1 is just intermediate. Just an intermediate transition product. So it is not mature enough, not good enough. That's why you create version 2. And after you create version 2, you think version 2 is good enough, but version 2 is still not good enough. You're not happy with it, then you create version 3. So you're going to abandon version 2, but you don't want to delete them, I say, because you want to keep it as a record. Now you propose version 3. Then again, you're still not happy with version 3. So you propose version 4. So once you have got version 4 and you are happy with it, so you say, okay, now we adopt IP version 4 as a standard, then everyone use it. So everyone use it happily. Okay, happily using version 4. Then version 5 is also another experiment. People produce version 5 and then use for certain purpose, which is not meant for internet access. And then that's why people do not adopt IP version 5 into the internet application. That's why they propose another one, IP version 6. So IP version 6, okay, is a replacement for IP version 4. That's why it is appear, but actually those IP version 5 exist, just like it is not being used for the internet. It is designed for a different purpose, and then obviously that is not popular, no one using it. Okay, so that's why I say some of these will actually trigger you. And I talk about IP version 6 adoption more than 10 years ago about the Malaysian government supports all the government agency in Malaysia supposed to be all IPv6, IP version 6 ready by the year 2008, 2008. But now it's already, when we talk about it, it was 2006 when I was in a meeting. This is at the national level that of meeting we're talking about. Okay, the government initiative would like to push IP version 6. The first one to adopt all the government agency. So by the year 2008, all the government agency in Malaysia will be using IP version 6. But until today, this is 2022, and we still don't see the sign of IP version 6 appear in a lot of agency. Even though if you are using IP version 6, you have to do translation in order for you to access the internet, So if you are using running on IP version 6, you cannot directly access the internet, because it is not compatible with IP version 4, right? So these are the things. IP version 6, IP version 4 is not backward compatible. Not backward compatible, This means if you want to fully adopt IP version 6, the whole internet, everyone must change. Everyone must change. So you cannot you cannot convince everyone to change. That's why you have to keep two networks. So you have to keep two networks, and your computer will have two sets of IP address. One is IP version 4, the other one is IP version 6. Right. So a lot of this one, I think if you pay some attention, then you will actually realize your computer connecting to an IP version 6 capable device, your computer will have two sets of address. One is IP version 4, the other one is IP version 6. Right? So these two are not compatible. So those computers on IP version 6, they want to access the internet, they have to do another round of translation from IP version 6 to IP version 4 again. If they want to stop this translation, can. The whole world internet all convert to IP version 6 overnight. Everyone use IP version 6, then you don't have to do this conversion. Otherwise, even now you are running IP version 6, you want to access the internet, you must have a mechanism in your network to actually do the translation from IP version 6 to IP version 4 so that it is compatible. So this is some sort of translation at the moment still required. But for if the whole world changed to IP version 6 already, then you don't need to do this translation. You cannot have a mixture. When you do a mixture, you have to have some translation. That's why it is actually a very tough road to get people to change. Very difficult, I trust you. You know, you want to convince everyone to change at the same time, difficult. Why? Some people say, I just bought my, routers, just 10 years ago, and my router so expensive, I haven't made enough money, I haven't made enough money out from my router, my investment. So why should I change? So they don't want to change because of a lot of reasons. So to get everyone to change, there is a very tough, very, very tough initiative. But slowly we are getting there, giving it enough time. All right. Any other questions that you would like to discuss? Yeah, if there's no other question, fine. Okay, I think you can. Just to remind you that this coming Saturday, I think there will still be another quiz on this IP logical addressing. So make sure you are not forgetting about the quiz. Make sure it's open for 1 whole day, so you cannot miss. I mean, if you miss, your friend, all of you friends, you should remind each other. So make sure that none of you are actually miss out the quiz. Yeah. The internet is confusing. The internet is not confusing. Its internet is so flexible. Just have to imagine. The internet is so flexible, allow anyone to connect to it. You don't have to do a network design for the internet. You just need to connect you just need to buy a router. And then when you buy this router can connect to one of the router, anyone. Your router just need to connect to any one of the router in the internet. Then you are part of the internet already. As simple as that. And then as long as you are running on TCP IP protocol, then you are part of the internet. So only these two requirements. You need a router and you need TCP IP. As simple as that. So the internet is do not have the fixed structure. Internet is a network that is so flexible. Do not have a fixed structure. You don't say that, oh, the internet is running on star topology. No. Internet has got no topology, right? It is so flexible that you can just do mix and match and without any problem. And this is the beauty of the internet. Because to do network planning for such a huge network covering, such a huge population of users is so difficult. But the internet can make it possible. Why? Because the internet is so flexible, and then the way how it works is actually once you get connected, the router will automatically route your packets to the destination, and you don't care how the router route your packet. You see, sometimes fast, sometimes slow. And there is never mind. You will still arrive. You see, at the end of the day. So that is the beauty of the internet, and you still remember the beginning of the internet is actually this network was designed for military. Why it was designed for military? Because during the war, people can bomb your equipment, people can bomb your network infrastructure. If I want to, I want to win the war, I will straight away bomb your network first so that you cannot communicate. So the first thing I'm going to do is to kill your network, bomb all your infrastructure. So this network, this internet, last time it was called the ARPANET. This ARPANET was created just to withstand this kind of damage. Even if your network has been damaged, but as long as some part is connected, your data, your message will still go through. So your communication will not break down. So that is the beauty of this ARPANET. And this ARPANET, after that, evolved into what we have, the internet. You see. So they all share the same characteristic. That's why the internet is so easy. You don't have to really design it. Of course, sometimes you got bottlenecks, that is true, because if you do not properly design something, sure, they will have some performance issue at some point. So it is different from the network technology that we are studying. For example, Ethernet, your Wi-Fi, your Ethernet. These are all small network at layer 2. Okay, so these are all local area network technologies, smaller network. That's why you need to design for you can afford to design the performance. So if you actually break one of the cable, your network doesn't work anymore under Ethernet, okay? Under Ethernet or under your Wi-Fi type of configuration. So it's a different type of technology. So the internet is so straightforward. You just get connected to one of the router, then you are part of the internet already. And even if you turn off your router, that will not bring down the internet. That will not cause problem to the internet. It will not, you see, because your router is off, then the packets will be routed through other routers, not necessarily have to go through your routers. There is no fixed path in the internet. That's why this is the beauty of the internet. So when people say, I want to destroy the internet, then that is not possible. It's impossible. It's just like when you watch in a movie, what we call this movie, Terminator, okay, Skynet. Okay, so when Skynet get connected, so you want to destroy Skynet, it's not possible because Skynet itself is the internet. So you cannot destroy the internet. Right. So this is one of the things lah. And it doesn't own by anyone. So that is the beauty of it as well. Okay. So I think this is very interesting, communication technologies that we have today. And then today, all our application running on the internet. So, of course, there are a lot of issues, performance issues that you have to address, things like that. And then you are getting faster and faster. The internet can only get faster and faster if you upgrade the layer 1 and layer 2 technology. Okay, only you upgrade layer 1 and layer 2 technology, then the internet can only get faster. So if you're still using some of the old one, but to the internet, it doesn't really matter, If I'm using a very high performance hardware for my network connected to the internet, and you are using some of the very old hardware, very old routers, your router is like, the 20 years old, my one is the state-of-the-art routers. It doesn't really matter. It will still communicate. This is the beauty of the internet. It will still communicate. It's just that my internet probably runs faster. Your internet probably runs slower because you are using some of the outdated, low performance network equipment. So as simple as that. But the communication is always there. You cannot cut the communication. You will always be connected, right? Regardless of what kind of hardware are you using. So this is actually the beauty. That's why people go crazy. That's why this internet is overwhelmed all other network technologies at layer 3. At layer 3. All the others network protocol at layer 3 will not survive because of this. Because the internet is so wonderful, so easy to deal with, so flexible. All the other layer 3 network technologies will require a design probably. Okay, they will require a certain design, and they do not have the features of just route things like that. Right. That's why I said the internet now under TCP/IP is actually one of our very unique scenario of network. A very unique type of network. Okay, so this is the story about the internet. And of course, the internet today is not running on TCP/IP only. There are 2 protocols at layer 4 that is actually can work with your IP. We always say TCP/IP, but actually it covers not only TCP/IP, it covers UDP/IP as well. Okay, so the layer 3 is IP, correct? The same IP. Layer 4, you got 2 options. One is TCP, the other one is UDP. And I think we're going to talk about it in our next lectures. So when you're dealing with the bank, when you're browsing a website, you are using the TCP. Right? You are using TCP protocol, TCP coupled with IP. But when you are going on YouTube, you're watching some YouTube video, and you are actually using UDP plus IP. Okay, so using UDP IP. So they have 2 different characteristics. So people have be able to introduce another protocol for the internet so that it can deliver video much more efficiently by using UDP. In fact, when we are doing this real-time conferencing, we are using UDP as well. No? We are using UDP. When you are using voice over IP to talk to your friends, talk to your mom or whatever, that is also using UDP IP. Okay, because UDP IP is very good for real-time traffic, very good for video time-sensitive traffic. They are very good. TCP IP is actually good in what? It's good in make sure that your data never lost. When you're dealing with online banking, you don't want your data to be lost, right? So that's why when you're dealing with online banking, when you're browsing a website, when you're reading news, when you're replying email, so all the stuff, they're all using TCP IP. Most of the time using TCP IP. Only when it comes to video, audio, video, audio streaming type of thing, then UDP will come into the picture. Okay, that's why I say when you're watching YouTube, these are mainly running on UDP IP. It's still layer 3, still the same IP. Only layer 4, you got two options. Okay, either using TCP or using UDP. All right, so I hope that is clear to you. By relating some of this to your real life application, then you will be able to see the network, the wonder of the network technology much more clearer. I hope this is helping. Okay. QR code, is it? Okay. Okay, I share the QR code again. Okay. Yeah. Okay. So, I mean, if you I think that is the end of our session. So, if there's no more question, then after you scan your attendance, then you can leave. I will see you again next week. Thank you very much. And have a nice day.